I'm Ojan. I am going to do a hopefully quick survey of things we've attempted. This was supposed to be a discussion, and then 100 people said that they would come, and this is not 100 people, which was great, because I'd rather have a discussion. So I'm going to do a thing where after each slide, I'm actually going to pause, like legit pause, and ask you for not just questions, but comments, thoughts, especially if you're one of the people who was involved in one of these projects. I would love for you to add things. I was involved in some of these projects, but definitely not all of them. So yeah, okay. So speaking of which, 4.5 years ago, I stumbled across this design doc I wrote as I was like researching for these slides. I wrote a doc about implementing things in a layered way, and still working on it. We haven't really succeeded, although we've made nice progress, I would say. There's many different reasons why we have attempted implementing things in a more layered way. Here's some of the more prominent ones. This is definitely not all of them. The first one, and this is the most often cited for sure, is it forces us to extract out the primitives that developers would need to implement the same thing as we're implementing. So a consequence of that is the second bullet is if we implement an API, let's say a virtual scrolling API, hypothetically speaking, and we wanted to meet 100% of all use cases you'd ever need with a virtual scroller. The inevitable result is we build a virtual scroller that is a big, bloated omnibus thing that solves everything poorly instead of 80% of the things really well. And so this would let us implement the virtual scroller that does the 80% really well and leave the other 20% for web developers to implement when they need to do one of those like bespoke use cases. But since we're exposing all the lower level primitives, then they can actually do with full fidelity the same thing that we do. Okay, another often cited reason is actually implementation oriented, which is a stricter layering means you have less spaghetti in your implementation of the platform, which in theory means you have a core that is more efficient. Not just in theory, in practice also. An example, I don't know if it's still the case after layout ng, but it used to be that block layout knew about the HTML dialog element. So there's like branches for the dialog element that were slowing down everything that wasn't the dialog element in block layout. And there's just like a long list of things like that, that if you have better layering, you just can't get in that situation in the first place. And then another somewhat less often cited reason is if these things are implemented in the same tools that developers use, they're more accessible to developers. They can file bugs more easily. They can like actually look at the code and be like, oh, that's where the bug is, and file a bug and let us know and that sort of thing. And in theory, get more involved in web standards, in designing these things, that sort of thing. So again, this is not the exhaustive list. Did I miss any big ones? Anyone else who's worked on this space?
Incubation is a possible one. Like if it lets anyone build these things and then we can just select from the popular ones and pull out the core functionality of it into a web component.
Thank you for speaking and making this a dialogue. All right, I'll move on. So this is getting into now the actual details. The first thing we tried, I think I got the chronology right here, but take with a grain of salt. I put dates where I could easily find them. Was called BlinkOn.js. Is Kentaro in the room? He's not. It's okay. He built this. And it was our first attempt at like, hey, what if we implemented these things in JavaScript? And it actually started, it's not in my slide here. Oh no, it is there. It started with us trying to get rid of XSLT from our, like the XSLT library was this third-party library that like was just like a constant source of security bugs, and it wasn't code that we wrote. It's code that like nobody cared about. Like developers didn't care about it. It was just a huge pain. So we used mscripton to compile it into ASM and see if we could like just take the legit like C++. I don't know what's happening. Okay. No. Well, they're muted now if they weren't. And so we tried that, and it turned out XSLT is hard. But that did sort of spur building out the infrastructure a little bit. And then we realized, you know what's not hard is marquee. Marquee is a pretty simple element. But the marquee code in Blink was written in like 2003, 2001 maybe. Like it might have even come from KHTML in the like 90s. It had the most absurd backdoors into the rendering code and was consistently a source of security problems, performance problems. It was amazing. And so we rewrote marquee in JavaScript in BlinkOn.js, so BlinkOn.js is, we generate C++ bindings from the same IDL we use to generate JavaScript bindings, but those C++ bindings then jump out into a JavaScript context that is not shared with the page. Did I get that right? Woohoo! All right. And as a result, we do a lot of jumping back and forth. It ended up being really slow. It ended up being a maintenance nightmare, I think, maybe? I don't know. It was very hard, particularly when you would try to use one of these things from C++. So we implemented streams. Was that the only thing? Sorry, I'm mixing up. I'm skipping ahead. Sorry, I'm mixing up. That's like attempt number 4. The swapping was expensive. Oh, right. And at the time, we had a strong resistance to adding backdoors. Part of the whole point of this was to like get nice layering. And the only way we could get BlinkOn.js to work was with a bunch of backdoors that like undid a lot of the layering. And so I put the layered but with backdoors as like a kind of shrug. It like got some layering, but it didn't get fully there. Okay, that's it for BlinkOn.js. What did I get wrong?
Oh, I just asked if I think the implication was that you since rewrote the marquee code again, right? Because I think I looked at it recently and it's not like that.
So this is in my final slide, but it's okay. We have unshipped every attempt we've done at any of these things. So if I say it's shipped, implicit is at some point later it unshipped. So yes, marquee is now not marquee is now normal C++. It's not a maintenance nightmare because we rewrote it in like modern Blink code. It was fine.
Yeah, I just wanted to add that we did rewrite it and then we rewrote it back in C++, but it uses like modern things like animation. So
yeah, it wasn't the old implementation that we brought back.
Oh, yeah, and I was just going to say that we liked your modern, the new approach, and I think we did something similar when we were getting rid of XPL. So
okay.
The C++, but leveraging modern things.
Okay. Attempt number 2 was position sticky. This was Rob's first project on the team. And this was actually the outcome of the doc that I showed in the first slide. It was right around that time I was making this impassioned pitch for how layering is awesome. And we're like, you know what should be really easy? Position sticky. Position sticky is so simple. Like, we must be able to do that in a layered way. And Rob took a valiant effort, and wow, did we find a lot of missing things. A lot of missing primitives. I guess just a lot of missing primitives.
It's worth noting, like, part of the reason we thought we could do this was we were working on Compositor Worker at the same time, and that was supposed to give us the ability to do this on the fast composited scrolling path. But yeah, it gets back to the missing primitives, why it just could not work.
Yeah, we thought the hard part was like, let us run this thing on this other thread. But it turns out the hard part is like all of the little things that makes it behave like a normal web API. Compositor proxy, is that what it was called back then?
It might have been UI Worker or
okay.
Compositor Worker.
It's all morphed into animation workload. So for your mental model. Any questions or thoughts about that? I love how leaning into awkward silence invariably someone speaks.
I want to highlight your first down bullet point. There's no way to add new non-dash CSS properties or detect like CSS modifications or add new property values. Like these are really hard problems to solve, and I don't think anybody even is trying to tackle them. Like everybody, Houdini and all that, those extensibility for CSS modern efforts, they're like, no, but we're going to segregate the user space things with dashes before them. So if you really want to be able to get an actual layered platform, it's not clear that there's consensus that people want that.
Yeah, like all of these things are still true today, I believe.
Yeah, we have not addressed any of these. So that didn't ship. It was a more like we did a prototype and we're like, okay, this is not gonna work, but it did expose a bunch of follow-up work that we did, right? So it was still not time wasted. Okay, and honorable mention is the web agents project. Most of you will not remember this because it did not get very far. This was an idea of mine that turned into an idea of Dimitri's, and Dimitri got really excited about it, and then we almost staffed a team on it, and then the team got reorged, and then it never happened. So what this idea was, I'm giving all that context for, this might still be a good idea. It's really hard to say. Like we never really gave it a try. What if we implemented things in a layered way, but still just in regular old C++? You're only allowed to use APIs we expose to web authors. We automatically generate C++ code from the IDL, and it at least gets the like no backdoors thing. You will never get into this marquee situation where marquee is like causing you insane pain. This code on the right, is an example of like what it would look like. You'll note that like that looks pretty close to JavaScript, like a little bit of tweaking, and that was the intention. We never actually built any of this.
The Chrome media controls are mostly using this pattern, even though it's not enforced by anything.
Sorry, that's a good point. I should have clarified that there is code, mainly the media controls, that do this ad hoc and informally, but there's no enforcement. This idea was actual build tooling so that like you couldn't do it.
There'll be a talk at 3 something about WebAssembly interface types, which suggests that maybe WebAssembly would be a way to do something that looks like this, because it would answer that implementing web features in C++ versions of JS APIs is awkward. We're trying to answer how to do that on the open web, so you could imagine doing that inside Chrome using WASM.
Yeah, let me explain what that one is. That's a good point. That one is, it's just sort of like most web APIs take a callback, and like passing a callback function in through C++, that's not a C++y pattern, right? And so you have to write this really strange C++ code. It's functional, you can do it. There's no like technical problem. So yeah, it'd be interesting if the solutions we come up with for WASM end up making this easy. That does seem promising. But again, never really staffed, never really built. Is Jeremy here? Hi. Jeremy wrote a rewrite proposal of this that was Web Agents Lite. That was like, let's not restrict to web APIs. That didn't go anywhere either, did it? Or did it?
Yeah, this is just basically me not wanting what you proposed and saying like, if we're gonna do that, let's do something instead. But I still didn't.
This is this is sort of silly, but I'm getting at a theme actually with all of our layering efforts, where there's been a lot of like false starts. But false starts we learned something from, so it wasn't just like a waste of time. And in many cases, there was output that shipped that was valuable, although not in this case. Okay, attempt number 3. This is one of the ones that shipped. V8 Extras. It used the same infrastructure V8 used to implement language features on top of JavaScript to implement more things. I think we shipped streams, just streams. And this is what I was referring to earlier when I was like, this got weird and awkward when you were trying to use streams from C++ code. This would have worked a lot better for things where we were confident we would never need to use it from C++ code. There was a whole talk about this at BlinkOn 2 years ago, maybe? Oh, was there another talk about it?
Yeah.
Okay, Adam Rice has been talking about the problems with V8 extras for a long time. And as of August of this year, they no longer exist. They were pulled out. And as far as I know, V8 no longer has any ways of implementing anything in JavaScript. So the V8's built-in JS mechanism is also gone. The specific the specific things I remember from the Adams slide deck are this one thing of using V8 objects from C++ was painful, and then the other is that in JavaScript any line can throw, and that writing C++ code that is secure against anything can throw turns out to be super hard. Hopefully I got that right.
And I think it's important to point out some of those are kind of just like nobody did the work. Like we could have generated bindings to make using them from C++ easy with a bunch more infrastructure work. We could have improved the debugging story with a bunch more infrastructure work, but nobody put that work in, and for good reason, I guess.
I think that's actually a theme throughout every single attempt we did. Most of these problems were solvable, but it turned out we didn't really think it was worth the amount it would take to solve them. So the debugging was hard. It's like, you can't use Chrome DevTools to debug this JavaScript, and you can't really use GDB. So, you're in this like weird limbo space. Any other thoughts or questions about this one? Behind you, Dominic.
Not really directly about this one, but I think this is probably the most similar you're going to get, as the extensions which is outside of Blink has had bindings which were historically written in JavaScript and have historically had a lot of bugs, especially security bugs, because they ran in the same script context as extension author script, which could vary and as a result they had to do a bunch of things where they pulled out built-ins in advance, and ultimately Devlin ended up rewriting their binding system in C++ and just generating, which led to a reduction of those sort of issues, and also had performance impacts because we could use things like V8 function templates that span contexts across an isolate that aren't things that are reasonable to exist in the JavaScript language. And so they realized performance and security benefits by rewriting their bindings from something that looked a lot like V8 extras but wasn't into C++ using Gin.
Yeah, those bindings were slow, like staggeringly slow, user visible slow, just doing like a single function call as they like instantiated all the bindings. That does remind me that, thank you, that's a good one I forgot about. I was gonna honorable mention in here also, just sort of like not really Chrome, but a lot of Mozilla's UI is written in JavaScript, right? And JavaScript and Zool and maybe now web components.
Yes, and it is. It was designed as the best biggest, most complex web technology app like 20 years ago, built with all this custom stuff like Zool and XBL, which we are now. I think we've just removed the XBL implementation and migrated everything onto web components plus like a few extra hooks, and we're moving more and more things to HTML. So Zool is on the way out.
That seems like a good example to me of a case where if we're willing to put the investment in to getting the tooling passable, it ends up being worth it. I don't know. That's my outside perspective, but
I can also say that it's worth drawing the distinction between programming the browser UI versus programming web APIs.
That was the big part of why I wanted to honorable mention it.
Right, exactly. And so basically we also we went whole hog in the same direction of doing a lot of web APIs in JavaScript, and we had a lot of the same problems you mentioned, plus some others, especially around security, and had to do a lot of work around that. And eventually, I think basically at this point, I don't know if we still have any, but we're trying to move away from that and back. Pretty sure at this point that implementing web platform features in at least, I wouldn't just say C++, but because we use Rust, but in a systems programming language, rather than in the web VM is the right approach for us.
Mm-hmm. Apparently, there's a question on the thing. I can't see it. What's the difference between V8 Extras and BlinkExtras? Go for it.
Yeah, I want to answer this because it was kind of something I also wanted to highlight about V8 Extras, which is it's the first approach here that runs in the same context as the page code, which brings along performance benefits and like to some extent mental model simplicity benefits, right? You don't have to like say like, oh, this is an object.prototype from the extension context or the BlinkNJS context and need to translate back into the other context. But on the other hand, it makes programming these things securely very hard, and robustly. In particular, so if you do like object.prototype.hasOwnProperty.call, whatever, there's like 10 different ways that page code could override those various functions and interfere with you just like checking if something has a property if you're sharing the same context. In V8 Extras, we were like, oh, the V8 team does this fine. They pull out all the originals, they use them, and they're smart people, and we're smart people. We can do this. And we only ran into a few bugs, and only a couple of them turned into security bugs. So. In particular, and I want to highlight one more thing, which is if you have any backdoors, then imperfect programming of that style becomes a potential security bug, right? If you have no backdoors, then imperfect programming in that particular way just becomes like a robustness bug. Oh no, somebody can interfere with your built-in code. But if you have backdoors, then it can become a security issue.
Right. Yeah. Any backdoors are now any issues in your code can do whatever that backdoor can do. That does remind me, actually, I want to, I haven't called this out very clearly, but let me start over. Yeah. While you're getting the mic, I'll say what I'm going to say. It's quick. Basically, there's a theme through all of these things of how do you hide the implementation details. And they all take a different approach. And as a result of that different approach, they all have different implications. So BlinkNJS, you hide it by running it in a different JavaScript context. V8 Extras, you hide it by grabbing the originals up front using bespoke, original methods of everything.
I have two questions. One is, did Firefox ever ship a web API backed by JavaScript? Really? Like which ones?
A lot of them were for Firefox OS, and so not super widely used and have been removed. But I think we. Is there a good example that's similar to for some reason, I'm having trouble coming up with one off the top of my head. Yeah, that's right. I'm not sure. Yeah, I mean, probably not. Web app manifest. Yeah.
And a bunch of SpiderMonkey. I mean, it's a little different.
Right. So, I mean, I think there's sort of two classes of, well, at least two classes of like stuff that we self-hosted. Like one of them was the SpiderMonkey stuff, like inside the JavaScript engine of like self-hosting ECMAScript built-ins, and that was done with a pretty different way, where it's just like all run entirely in the it's all run in the same context, and it's just done very, very carefully with intrinsics. So you have to, it's like really rocket science to get it right to be able to, do this unobservably. And then what we were doing for the web APIs, for the sort of WebIDL APIs, was that we would have a bunch of C++ glue. So you would call from your JavaScript down into C++, and then you end up back in a different JavaScript context, which uses our X-ray wrappers, which are a mechanism by which you can kind of like have a view of a different JavaScript context that has, sort of all of the originals. Like I know that Blink uses separate worlds into some. It's similar but different. But I think we did definitely ship some things to the web, and I can figure out, or like some things that were pretty widely used that we have since rewritten. I can figure out what those are.
I was just wondering if there's anyone from the V8 team who could add any additional learnings from the BlinkNJS or V8 Extras approaches.
I would like to do that, but I'm going to actually interrupt that. We have 3 minutes left. So I'm just going to try to get through all the remaining slides, and then we can have
So very quickly, we used to also have JavaScript built-ins written in JavaScript, and that turned out to be a very bad idea. Due to the same reasons, we had backdoors called intrinsics that, JavaScript is JavaScript. It throws, it has side effects, and that can easily lead to security issues. So now we have a DSL to implement those intrinsics, to implement those built-ins. and that has reduced these sorts of issues quite a lot.
A quick answer to Bo's question. I believe the way you get backdoors in V8 Extras is V8 gets to run first, and so it doesn't need to do anything special. It can just save off the ones it knows it needs. All right, I'm going to rush through the rest and unfortunately have less dialogue. There's not too much left. Okay, our most recent effort is layered built-in modules. At various points, we call this a bunch of different names. Built-in modules is a thing that's still happening, but built-in modules can be implemented in C++. I kind of made up this term, layered built-in modules, for built-in modules that are implemented in JavaScript. This isn't actually a standard term for it. And it's basically, what if we made it so that these things are actually just regular JavaScript libraries, the same as any author would make, which would require them to import them the same as any author library code. They would run at author privileges with like no special powers. And we went pretty far with this, and it's really only in the past month or two that we've wound down this work and are replacing it with some other things, which I'll talk about later. But some of the issues with this, so some of the good things, this did legit work really well with the DOM team, where we exposed a bunch of accessibility primitives, for example, that we needed for toggle switch that have now shipped. They've been useful, they've been well received. It made for a very efficient, tight feedback loop. So that was a huge success. We had hoped it would work out that way, and it did. You could use the regular Chrome DevTools, so debugging was easy. The performance was basically the same as any other author JavaScript. So there wasn't some weird, unexpected thing, but there were a number of problems that basically came down to, as a web author, you expect the built-ins to behave a certain way, but you don't necessarily expect random JavaScript libraries to behave that way. There's a bunch of things you need for self-hosting that are not actually useful and nobody cares about, but it's weird for the built-in thing to not have that. Let me think, what's an example? Is trusted. Oh, is trusted on events is kind of a weird feature in the first place. It doesn't do what anyone thinks it does. It needs special privileges to implement, though. So if you're implementing at author-level JavaScript, you just can't do it. And so we would need to extract out a primitive so that author-level JavaScript could do it. We do all this work and churn for a thing that nobody cares about. So, and then the way this hid implementation details was an API called getOriginals, which we discussed at TC39. It is stalled. Is that the right word for it? I don't know. It was, we never finished this. It was unstaffed, yes. Okay, so that's it, kind of, in that these are the ones we've tried. There's a couple that are either in progress or not yet disproven. And I'll go through those real quick. BlinkExtras is one of the not yet disproven ideas. No one's actively working on this. But it's a slight tweak that we've never explored that might still be worth exploring, in my opinion. It's basically like a layered APIs, but without the import statements. If V8 Extras and layered built-in modules had a baby, you'd get BlinkExtras, which is you rely on extracting out the intrinsics you need up front, and you don't require an import statement, but you're still running as unprivileged author code. Sorry, that's not quite right. It allows backdoors. So you don't have any special JavaScript mode. There's nothing special about this code except that it gets to run first. Did I say that right? Close enough? Yeah. Okay. And then this actually is a work in progress discussion. There's a talk about it tomorrow that Rob is running. Web shared libraries, it's initially a proposal from Mozilla, and actually Bobby from Mozilla is here, so hopefully. I would say it's a brainstorming exploration. Yes. Yeah, a proposal is overstating it. But it's basically, what if these things were legit, actual, regular JavaScript libraries? The browser doesn't know anything about them, except we add some hooks to do really powerful cross-origin caching while still being privacy preserving. And that last bit is the tricky bit. This has all the advantages of the other layering approaches. It has the author expectation advantage of like authors don't expect is trusted to work because it's just a JavaScript library. There's I put a bit of a like meh for there's an open question on whether we'd standardize any of these, and I think that goes both ways. On the one hand, we don't need to standardize them, so that's great. It means like anyone can build these things. Library authors can compete with browser components on an even playing field. On the other hand, the way that a lot of these projects started, I'm going to give a short, oh, we're way over time, aren't we? All right, I'm going to 1 minute. The way a lot of these projects started was a few years back, I was trying to teach myself Cocoa, like macOS Cocoa. And every single tutorial said, all right, here's how you set up your project. Now go use a UI table view. Now do whatever, whatever. And as a result, everybody who started in building a Cocoa app got this really efficient rendering experience that UI table view gives you. Everybody on the web puts a div and maybe overflow auto and gets this order n rendering experience. UI table view gets you this like constant time rendering experience as you add more code, roughly. And I think a lot of that comes from there's a default expectation. The platform ships UI table view, like it's just there. All the tutorials assume it's there. You don't need to go get it from somewhere else. And so this unclear if we standardize is kind of like a meh thing. But what I like about web shared libraries is we don't have to make this decision up front. We can ship the ability to share. We can see how it plays out in the wild, and we can figure out what the best thing to do as we go. The really hard thing is privacy. If we do this naively, it's a simple tracking vector. And all of the solutions we've come up with lose a lot of the performance benefit. But we have some ideas that seem promising, actually. So that sounds more negative than it actually is. All right, that is it. Sorry, it went over. OK. If anyone has some last questions or thoughts. All right, let's call it. Thanks.